Okay, so we're going to begin with section 3.4. 3.4 talks about proving lines parallel. If you see this word proving, you should think that we have to do some proofs, and that's true. We are going to do some proofs. The first thing we need to do is discuss this idea of a converse, because the reasons we'll use are going to be converses. So if I give you a conditional statement, if P, then Q. Remember that we identified P and Q as the hypothesis and the conclusion. So then the converse is when they switch. So you would say for the converse of the statement above, if Q, then P, right? So the Q and the P switched places. So they switched. So that's all we're going to use for these theorems we're going to talk about today. We're just going to switch them around, okay? So we're going to use shorthand for these theorems because I don't think you need to write them all out. So converse, and from now on we'll use CV. Converse to corresponding angles postulate. Okay? Remember, the corresponding angles postulate said if two lines are parallel, cut by a transversal, then corresponding angles are congruent. Now it works backwards. If corresponding angles are congruent, then lines are parallel. Okay? So again, this says if corresponding angles are congruent, then lines are parallel. Again, using very short, okay, very shorthand, but it's the converse, okay? Similar idea for all the other ones. The converse to the alternate interior angles theorem. So again, it's a converse, CV, converse. If alternate interior angles are congruent, right? They're the ones that are congruent, then lines are parallel. Okay? The next one is the CV to the alternate exterior angles theorem. Again, it's just the alternate exterior angles theorem flipped around. If alternate exterior angles are congruent, use the symbol, are congruent, and you can feel free to write it out, then lines are parallel. And lastly, we will do the CV to the same side interior, to same side interior angles theorem. And this one is the different one, right? Because same side interior angles, if same side interior angles, the SS, like we're naming a ship, if same side interior angles are supplementary, then lines are parallel. Okay? So we're going to do one proof, maybe two here, using these ideas. Okay, so let me create a problem and then we'll move on. Okay, so here's the problem. Here's the proof setup. I would say you should give yourself a chance to write it down and then listen to me talk. But I'm going to move on. It says angle 1 and angle 5 are supplementary. Angle 1 and angle 4 are supplementary. You need to prove that lines J and K are parallel. Alright? So you always start with the given. I'll use a different color to write in. Okay? So we always start with the given. The given here is that angle 1 and angle 5 are supplementary. Angle 1 and angle 4 are supplementary. Okay? And that is the given. Now, as I'm looking at this picture, I want to say that J and K are parallel. So, in the end, you need to be thinking that what do we need to say about 4 and 5? That's the question. Because they're the ones that are involved with J and K, not 1. And if you look, what kind of angles are they? They are alternate interior. So can we get them to be congruent? If we can get them to be congruent, then the lines are parallel. So let's work our way down to that. So statement number 2. If they are supplementary, then we know that their sum is 180 degrees. Measure of angle 1 plus the measure of angle 5 equals 180 degrees. The measure of angle 1 plus the measure of angle 4 equals 180 degrees. And that came from this word. So it's definition of supplementary angles. Definition of sup angles with the symbol. Okay? That's how we got those two statements. From this word supplementary, we were able to write these two statements. So now, look at what's common to both. There's a 180 here and a 180 here, and I also see angle 1 and angle 1 there. That's good. But look, if they're both equal to 180, then we can do a substitution and say that these two sums are equal to each other. And that's exactly what step 3 is going to say. The measure of angle 1 plus the measure of angle 5 is going to equal the measure of angle 1 plus the measure of angle 4. So we took out 180 and we put one of these sums in its place. So we wrote measure of angle 1 plus measure of angle 5 equals, took out 180 and put this sum in its place. Because the sum is also equal to 180, so it can be replaced by substitution. Now, notice what you have. You have angle 1 on both sides. Get rid of it. Subtract the measure of angle 1 from both sides. So you'll arrive at step 4, which will isolate angle 5, so the angle 1's cancel, equal to the angle 1's cancel, the measure of angle 4. And you just subtract it, so that's subtraction property. Okay, I have to slide it down a little bit. Let me see if I can keep the picture. I'll go that far. Let me extend my statements and reasons. So we talked about 4 and 5 are alternate interior angles. Can we say they're congruent? Well, look, their measures are equal. So by definition of congruence, we can say that angle 5 is congruent to angle 4. And that is by the definition of congruence. And look what we've done. We have shown that angle 5 and angle 4 are congruent. And they are alternate interior angles. So, by the converse to the alternate interior angles theorem, we can say that lines J and K are parallel by the converse to the alternate interior angles theorem. And there's the proof. And I wonder if I can scroll up a little bit. I'm cutting it off. If you look at your picture in the proof, notice that we took the information we were given and we used it, okay? But before we even did stuff, we talked about what situation would we like. We talked about here's J and K. They have 4 and 5, angles 4 and 5 on them. Can we make a statement about them? Well, yes, we can say that they are going to be alternate interior angles. So to prove lines parallel, alternate interior angles must be congruent. So were we able to make 4 and 5 congruent? Yes, we were. So we showed the lines are parallel. Okay. So when you come to class on Wednesday, we'll be doing a couple proofs, and we'll get good at them. All right. Have a great weekend.